In this video, we're taking a look at naming acids and writing the formulas for acids. Essentially, if you take a look down this column right here, what an acid is an ionic bond between a positive hydrogen ion and a negative anion. And when you put it in water, what happens is these two separate. So you'll usually see, especially with the binary acids, the ones that are just composed of hydrogen and one other element, this AQ symbol after it. This means aqueous. Is just telling you that this compound is dissolved in water, making it indeed an acid. Okay. And when we're paying attention to the names of them, it's this anion that's going to give us a lot of information about how to name it or what the formula should be. So got our little flow chart right here. Basically, the first thing you should ask yourself when you're trying to decide how to name this is if there's oxygen in the anion. Okay. If there's no oxygen there, you're going to begin it with the word or the root hydro. You're going to put the beginning of the anion, end it with ic and an acid. So, for example, let's say that we had HBr. Does it contain oxygen? That would be no. So the way we would name this would start it with hydro. The root of the anion is the second one, the negative ion. So this is bromine. So this would be brome. And then we change the ending to ic. So that'd be just hydrobromic acid. Okay. Let's say instead that we do have oxygen present. Well, when there is an oxygen in there, an example would be this compound right here. If there is, we have to take a look at the anion and find out if it ends in ite or ate. PO3 is phosphite. And if there's a ite at the end, we change it, the ending to OUS. Okay, so this would be phosphorus, or with phosphorus it becomes phosphorus acid. Okay. And then we have another ending. We have an 8 that's possible. So instead of that, let's make it with phosphate. In this case, we would write the root of the anion, phosphate. Again, with that, you write the whole thing, phosphorus. Okay. Instead of OUS, it'd be ic. So this would be phosphoric acid. Okay. So I've got some more examples up here. We can work through them. First one here, H2Cr2O7. Okay, so we're asking ourselves, is there oxygen? And yes, there is. So we need the root of this polyatomic ion. So if you look on a list, you can find that Cr2O7 is dichromate. So we would call this dichrome. Instead of 8, we change 8 to ic. Okay, I ate something icky. I ate something icky. 8 and ic go together. So this is dichromic acid. Okay. Next, I have just HCl. Or first thing you want to find is oxygen. There's no oxygen. So when there's no oxygen, you automatically start with hydro. Now, the anion this time is chlorine. Cl is just chlorine. So you write the root of that. Hydrochlor, add ic, and then acid. And the third one, we do have an oxygen, so we're not going to have hydro. We're just going to start by naming the root of the polyatomic ion. SO4 is sulfate, so the root would be sulf, and we add ic, so sulfuric acid. Okay, sulfate, ate something icky, sulfuric acid. This time we have H2SO3. All right, there is an oxygen, and SO3 is sulfite. So when we have ite, we change our ending to OUS. So this time it's going to be sulfur OUS, sulfurous acid. And when we want to write the formula for an acid, essentially we're just working backwards. We have to think of it in the opposite direction as we did here. Okay. So I see the word oxalic acid, and I notice that there is no hydro in the beginning of it, so it's going to have an oxygen in it. Remember, if it started with hydro, things that start with hydro have no oxygen in them. So I know that because oxalic acid does not have the word hydro in the beginning of it, there is an oxygen somewhere. So now I need to take a look at the ending of it. I see that it is ic, and remember that ic goes with 8. So basically I'm going backwards and replacing this with 8. So I'm looking for oxalate this time. And on your periodic table, we have oxalate, and it's C2O4. So I know it's going to have C2O4. All the acids have a hydrogen on them. Now we just have to determine how many hydrogens we need. Well, each hydrogen is a +1, and oxalate is a -2, so it will be H2, 2 hydrogens to balance the -2 charge from oxalate. Now we have carbonic acid. Again, no hydro at the beginning of this, meaning that it will have an oxygen. So I shift my focus to the ic at the end, and I know that ic is 8 on the polyatomic ion. So carbon 8 is CO3. It's going to have a hydrogen. Now we just need to know carbon 8 is a -2. So I need 2 hydrogens to balance out the -2. Hydroiodic acid. Okay. Well, this time I do have hydro, so that tells me that this is going to be a compound that does not have oxygen in it. And almost always that means that it's just an element on the periodic table. So which element has the root iod? Well, that's going to be iodine, which is a -1 ion. So all I need is 1 hydrogen to balance it. Phosphorus acid. Okay. No hydro, so going to be a polyatomic ion. This one ends in OUS, and we know that ITE is where this came from. So we're looking for phosphorusite, or we know the polyatomic ion is phosphite. So it's going to have a hydrogen. Phosphite is PO3, and phosphite has a -3 charge, meaning that we need a 3. We need 3 positive hydrogens to balance out our 1 -3 ion.